All right, virus and worms, viruses and worms, module 7. We're going to sort of continue our discussion here. In our previous two modules, we talked about spyware, we've talked about trojans, and now it's time to talk about sort of the other categories of malware, viruses and worms. So our module objectives. We're going to see some repeating themes here as far as infection vectors go. We're also definitely going to talk about, the characteristics of viruses and worms, and so forth, which makes a virus different from a worm, etc. But as far as our eradication and our detection methods, we've got a lot of this information established at this point. So introduction to viruses, stages of virus life, workings of viruses, indications of a viral attack. How does a computer get infected by viruses? Virus analysis, types of viruses, virus maker, computer worms, worm analysis, worm maker, malware analysis procedure, online malware analysis services, virus and worm countermeasures, antivirus tools, and pen testing for virus. Now we do have a few labs that we're going to be looking at in our virus module at the end of the module. So we're going to look at the disassemblers and so forth. So introduction to viruses. A virus is a self-replicating program. Criteria number 1. Criteria number 2, it infects other executable files. So it requires a file for infection, and then it makes copies of itself and actually spreads. So it is a self-replicating program, and it creates copies of itself by attaching to another program, computer boot sector, or document. So we look for executable functionalities in documents, boot sector, and then also other executable files. Viruses generally transmitted through file downloads, infected flash drives, and as potentially email attachments. So the characteristics: infects, transforms, may encrypt itself. Not always the case, but as far as encryption goes, if the virus is encrypted, how are we going to scan for it? The signature string detection is based on a known specific code string, and if we can't scan that code, we can't detect it from a scanning standpoint. So encrypting alters that signature string. We also have polymorphism and metamorphism we'll talk about. Alters, potentially does self-propagate, corrupt files and programs, and then potentially alters data. So statistically, we've seen a pretty rapid progression from 2008 to 2012 for the known viruses and worms. So going from 11 million to 70 million in 4 years. So that's a substantial increase without a doubt. All right, our stages of virus life. All right, we've got the design, the replication, the launch, and so forth. So in design, we create the virus using a construction kit or actually writing the code from scratch. So the developer writes the code, and then in our replication phase, the virus actually spreads. So at this point, we may not see a payload yet, which is whatever malicious activity the virus is going to perform. But the launch phase, where the virus actually gets executed, at that point we see a negative impact on the system, and that raises eyebrows. At that point, we look for potential infection. So that's the detection phase. A virus is identified as a threat infecting target systems. Incorporation is the inclusion of a defined or discovered signature string, unique string, in the virus code itself that allows for signature scanning for the antivirus vendor. So it incorporates it into the database. Elimination is the actual cleaning or removal of the virus, deleting the infected files, and so forth. So working a virus. In the infection phase, the virus replicates itself, attaches to an exe file in the system, and we see this, just the graphic before and after infection shows that the virus is infected, created a jump instruction at the file header, the virus executes and then calls the original program. So it maintains the original program's functionality while executing. Not dissimilar to the binding process that we looked at in the Trojans and Backdoors module. All right, some viruses are programmed with trigger events. So the term logic bomb. The bomb is the payload that the virus delivers, whatever that may be, and of course that's going to be negative in nature. So the trigger event indicates when to deliver the payload. So that's the logic in the bomb. A time bomb would be logic that's a time-date condition. So some viruses remain dormant until a predefined condition is met, time, date, etc. User-specific task, time of a particular event, which I said that twice, and then actually release the payload or run an infection. So we see sparse infectors and rapid infectors. Why do people create computer viruses? Why do people do anything that's malicious in nature? They do, for whatever reason. The inflicting of damage to competitors, financial benefits, research projects, play pranks, vandalism, cyber terrorism, distribute political messages, to name a few. Indications of a virus attack: something is abnormal with the system. Processes take more time, more resources, computer beeps, no displays, screen flashes. The antivirus alerts you to the presence of a virus. That's pretty conclusive. However, not all abnormal activities or anomalous activities are attributed to a virus. So just because your PC is running slow, or you've got processes that won't launch and so forth, applications won't launch, computer reboots on its own. Not always a viral issue. Could be a hardware or even a hardware or software issue. So false positives are what we think are indicators of malware, but all they really are glitches in the system. So false positives not attributed to a virus. How does a computer get infected by viruses? We could summarize this slide by saying copy ones and zeros onto the box. So copy a file down. User accepts a file and downloads without checking for the source. Opening infected email attachments. Installing pirated software, very common infection vector. Going out to file downloads using like Newsleacher or any of your peer-to-peer file sharing utilities. So installing pirated software. Not updating and not installing new versions of plugins. And not running the latest antivirus application, not running an antivirus application that's had the signature database updated recently. All right, common techniques used to distribute malware on the web. Search engine optimization is a scenario where you are, for competitive edge, businesses would love for their websites to show high in search rankings. So search engine optimization is a methodology that's used to creep up your search results in search engine pages. Black hats can leverage those same sorts of techniques to rank your malware pages highly in the search results. Social engineered clickjacking is just straight away tricking users to click on what are innocent looking web pages that are actually malicious in nature and causing potentially the automatic download of the virus. Spear phishing sites. Phishing in general is sending out emails hoping that somebody's going to bite. So clicking on a link, taking you to a bogus banking site, entering your username and password, credit card information, and so forth. So spear phishing is more targeted towards a specific user group, users within the organization, etc. So spear phishing sites. Malvertising, putting malware inside of ad networks that are actually displayed. One of the major sources of revenue for standing up a website is advertising. So by embedding in advertising networks that are displayed across multiple sites. Compromise legitimate websites, actually attacking a legitimate site and putting infected files up on it for purpose of download, for example, or compromising legitimate websites, causing them to auto-download. Drive-by downloads, exploiting flaws in the browser software just to install malware by visiting a web page. Lots of potential methodologies for doing that. So the drive-by download is potentially spear phishing sites, still logging credentials, etc., compromise legitimate websites, and social engineering clickjacking. If you get an email saying, warning, the XXX virus, the XYZ virus, the ABC virus, whatever the case may be, is propagating throughout the network, download this file to protect your system, when in essence the file is actually the virus itself. So it can be a fake attachment, fake antivirus. The whole purpose is to damage the target systems, similar to other malwares. All right, DNS changer. With the analysis slides, again, for the Trojan analysis, worm analysis, and so forth, I'm going to let you just read those in your spare time. But we are going to take a quick look at DNS changer. DNS changer, Aileron, modifies DNS settings on the victim's PC. And the whole purpose of that is to divert to bogus copies of websites, malicious websites, generate fraudulent ad revenue, sell fake services, steal personal information. So it actually made just a change to the name server configurations in your TCP/IP settings and modified it to point to the bogus or point to the malicious DNS servers. So part of the FBI's botnet takedown FBI took ownership of the rogue servers to ensure those affected did not immediately lose the ability to resolve DNS names. That means is when they took down the malicious sites, they actually turned them back to legitimate DNS servers, and that allowed the victims to continue to resolve DNS names and continue to be able to browse the internet. So the rogue DNS servers just listed as the specific ranges for the servers. Nothing really too notable there. And the types of viruses. So virus types are classified by what they infect and how do they infect. So we're going to see an example of each one of these guys as we move through the next slides. System or boot sector viruses will actually infect the master boot record of the system. So they relocate the original MBR, they then run, they call the MBR, and this ensures that they run every time the system is booted. File and multi-part type viruses, viruses infect executable files. Pretty straightforward there. Multi-part type virus infects both files and the boot sector. So sort of an equal opportunity infector, I guess, in that respect. Macro viruses. Macro viruses infect macro functions of Word documents, Excel spreadsheets, PowerPoints, as a few examples. So they're actually written in a macro language for visual basic application, and it is a infector, a malicious portion of code inside of a template, convert infected documents into template files, maintain their appearance of ordinary document files. Cluster viruses will actually point to a single viral code location. So what they do is they go in and they modify directory entries for the files that they are infecting, when in essence they're just changing the pointers to point to the clusters occupied by the viral file. That runs and then calls the original file. There's only one copy on the system. It will launch itself before any program and then pass to the actual program. Stealth viruses attempt to evade detection by diverting to scans of an uninfected copy of the file. So they evade antivirus software by intercepting its request to the operating system and intercepting the software's request, passing the request to the virus instead of the OS. The virus can then return an uninfected version of the file, and that appears to be clean. So pretty cool. Tunneling viruses. Tunneling viruses will attempt to tunnel down into lower layers of the operating system, areas that are not actually scanned by antivirus software. Encryption viruses. If we've got signature string detection going on, then we're looking for a specific signature string within the viral file itself. If that's been encrypted, there is no signature string. It's been encrypted. It's been garbled. So it's not going to look like the original. That's, again, one of the basic premises of encryption. So AV scanner cannot directly detect using signature detection methods. Polymorphism and metamorphism are pretty synonymous in functionality. They create mutated but operational copies of themselves. So it mutates while keeping the original algorithm intact. Enable polymorphic code. It has a polymorphism engine, mutating or mutation engine. The idea is it makes varied but operational copies of itself. So with the varied copies, you've got a altering of the data. Signature strings don't remain intact, and we can't pick up different variations of that. All right, so metamorphic, same idea. Metamorphic rewrite themselves completely each time they are to infect a new file, where polymorphism actually has a mutation of the original code. So same idea, a little bit of different methodology on that. All right, file overwriting or cavity viruses. Cavity virus overwrites, hollows out part of the file, overwrites it with constants and so forth, and actually can preserve the file size. Sparse infector viruses infect only occasionally. 15th execution, 20th execution, 10th execution, etc. And by infecting less often, they are less likely to be detected. Companion or camouflage viruses are a companion file to a legitimate system executable. So for example, if I type in Notepad and I hit start run Notepad, I don't specify notepad.exe. So anything that matches that Notepad extension, that Notepad with a different extension, could potentially run. Now your load order and you looked at the path for the executable and so forth match, but your load order is .coms.bats.exe. I'm sorry, .coms.exes.bats. So if I have a notepad.com and I just type in notepad, notepad.com gets called, and we can see by the skull representation here that that's a malicious copy of the file. Shell viruses wrap themselves around or prepend to the program. Pretty much enough said there. Almost all boot programs are shell viruses. File extension viruses change the extensions of files, doubling up. So the extensions of files, the double extension, we double click on what looks like a text file, for example, and we talked about what the double extensions, the default nature of the operating system, hiding extensions for known file types. We talked about that in the Trojans module. Add-on and intrusive viruses, append to or write into, plain and simple, without making any changes to the latter, or relocate host code to insert their own code at the beginning. Direct action, or transient virus, transfers all controls of the host code to where it resides, such the target program to be modified and corrupts it. Your standard action for a virus is typically launch, execute, go dormant again, or go back to sleep. Terminate and stay resident viruses actually run and stay in memory. So if you were to clean the infected versions of the file, infected copies of the file, you'd have to reboot the system to actually flush the TSR out of memory. And they could also remain, resident, looking for indicators to deliver a payload. So it remains in memory. Writing a simple virus program. Well, for writing a virus program, then we're talking about virus should infect and make copies of itself. This game.bat file, which a lot of times viruses just use loosely to identify any malicious software, which this game.bat file definitely is malicious in nature. So when I was way back in 1999, when I first started teaching, we used to do this, what we called it floppy bomb night. And it was in like DOS Windows or A+ class. So we did our autoexec.bats, and we used like del part commands and so forth. So we just had a little fun with writing some potential malware and some different versions of that. So the game.bat is just a malicious bat file. So pretty similar to what I just talked about. You create a batch file. That batch file can be on a boot disk, delete partitions, things like that. You also have the batch file that most definitely runs within the operating system as well. So autoexec.bats and so forth historically, booting from a malicious disk, etc. All right, so in this situation, we're deleting all the files in like the system32 directory. We have virus construction kits. So Terabit Virus Maker, JPS, and Delms, Batch Virus Maker, all construction kits that allow you to send spam emails and so forth, disable the registry. So you've got some construction kits similar to what we saw in our Beast and Spytector construction kits. All right, the worm. All right, the worm is a freestanding autonomous program. They replicate on their own. They may actually just consume system resources, and they may actually carry like a virus along with it for purpose of infection. So most worms are created only to replicate and spread across the network. Some worms actually carry a payload to damage the host system. So a worm is different from a virus in that it spreads on its own. We've already established that in the previous two slides. It takes advantage of file or information transport features on computer systems and spreads through the infected network automatically. Virus does not. Virus has to execute alongside the executable program. All right, Stuxnet. Again, with the worm analysis, I'm going to let you sort of read through these. But Stuxnet was actually targeted towards Iraqi infrastructure programmable logic controllers. So the idea is that it spread on its own and eventually would modify code on the Siemens PLCs to potentially sabotage the system, cause generator failures and things like that. All right, we have worm maker things, like the worm construction kits. So the same as Trojan horse construction kit, the same as a virus construction kit, we got worm construction kits. All right, the sheep dip. All right, sheep dip, historically the term is, it's similar to if you were to introduce a new sheep into the flock, you might actually treat it for pests and so forth so that it doesn't infect other sheep. So that's sort of the term comes from. Sheep dip is a staging area to inspect a file before it is introduced into the production environment. So it can be a system that's historically designed to check physical media, and then also the sheep dip computer is a staging area that's just loaded up extensively with detection software. So device driver and file monitors, registry and kernel monitors, user group and permissions process monitors, port monitors, antivirus, and so forth, to determine if a file is malicious in nature before it is actually introduced to production systems. So it's a staging area. Antivirus sensor systems. Antivirus sensor systems are going to allow us to detect based on antivirus software, plain and simple. So really nothing too terribly complex there. Of course, the detection methods can be, but there we go. All right, preparing a test bed. Create a isolated system, and VMware Virtual PC, great option for this, but make sure that the NIC is isolated. Make sure that you're disabling shared folders. There's guest isolation. Make sure that the malware can't actually propagate through normal infection channels, file sharing, things like that. We can also look for string values. Now, I showed you some examples. Strings can give us some insight into what the code's doing. They're ASCII strings, variations of that. And we actually took a quick look at that in Process Explorer. Sorry. All right, then UPX is a packer, and I talked a bit about packers in the Trojans and Backdoors module, some of your more advanced binding utilities. Set up a network connection and check that it's not giving any errors. All right, so static analysis versus dynamic analysis. Static is the file is shut down. We use a disassembler. Debugger actually executes it, but disassemblers, text extractors, look for the fact is it packed or not, and then set up a network connection. This is more dynamic analysis. Set up a network connection and check that it's not giving any errors. So in static analysis, we don't run the file. In dynamic analysis, we do, and we take a look at what the virus is doing. All right, record network traffic. And determine the files added, processes spawn, changes to the registry monitoring tools like Redshot. All right, OllyDbg is a debugger. We'll see an example of this in the lab. IDA Pro as well. We'll also see an example of that in the lab. Online malware testing is typically a submission to an online provider that basically you upload the file, they scan it, and report back whether or not the file is found to be infected or not. Online malware analysis services, Anubis, Avast, Trend Micro, House Call, etc. And then our countermeasures. Scanning for signature, integrity checking, reading the entire disk, recording integrity data. So we talked about like tripwire, FSUM, and so forth. And then intercepting the actual calls themselves. All right, install antivirus software, generate antivirus policy, pay attention to instructions while downloading. Identifying file signatures, checking the download, making sure that it matches the signature. Update by antivirus regularly. Avoid opening attachments from unknown locations. Maintain data backup. Data backup, so if we've got corrupted data, it can actually be restored. Schedule regular scans for all drives. Don't accept disks or programs without checking them first. Ensure the executable code in the organization that's being put in production is actually approved. Run disk cleanup, registry scanner defragmentation. That cleans up any performance impacting functionalities. Do not boot the system with infected disk. Turn the firewall if the OS used is XP. Why the firewall again? We've discussed this sort of in a roundabout fashion, but if the virus tries to call home, the worm tries to call home, the Trojan tries to call home, etc., and the malware tries to call home, let's just go with that, then there's an outbound connection request, and the firewall should actually ask you, do you want to allow this to go outbound? Know about the latest threats. Run anti-spyware or adware once a week. Check the DVDs and CDs for virus infection. Block files with more than one type extension. Ensure the pop-up blockers turn on, and be cautious about files being sent through instant messenger. All right, so a couple antiviruses: Immunet, AVG, Kaspersky, Symantec, etc. And then pen testing for viruses. So, test for suspicious system. Is antivirus installed? No, install antivirus. Is it updated? No, update it. And then scan the system for virus. Virus is found? No, system is not infected. Not 100% accurate, or 100% assuring. There could be viruses that are unknown, one-offs and so forth, that we may not actually detect. Set the antivirus to quarantine or delete the virus. Virus is removed. Yes, system is safe. We'd like to believe that, but again, there could be viruses we don't pick up. Go to safe mode and delete the infected file manually if virus is not removed. And then right back to really most of the things we talked about in Trojans and backdoors. Scan for running processes, registry entries, Windows services, startup programs, file and folder integrity. What's running could work for a lot of these. We talked about that in Trojans. Scan for modification to OS files, document all findings, virus detected, no. Is it updated? No. Update and run. If it is, if they are detected, isolate the machine from the network. If updated antivirus is running, yes. Find another antivirus solution to clean the viruses. All right, and that wraps up our viruses and worms module.